Great stuff. So I'm very happy to be talking at this session. Sorry, I can't be there in person. I've got other commitments, sadly, but very happy to give a talk for Midland Science and science communities on this very special forum on viruses, vaccines, and immunology, because it's such an important topic, isn't it? And I'm an immunologist, is my day job. And I've worked on inflammatory diseases mainly, actually, has been my real focus because that involves a dysfunctional immune response. But I've also worked on infectious diseases over the years because you can't really avoid that if you're an immunologist. And we've got 4 projects on COVID in my lab as we speak, and I'm going to talk about 1 or 2 of those. But obviously enough, I'm going to give you an overview of where we're at with COVID-19 at the moment. Obviously, I've been talking a lot about it in the media, and I'm very happy to share the knowledge I've got. I know all the people in the COVID world, kind of. I know several people who made the vaccines, as I've explained, and they were keeping me updated all through this, and I was able to tell the public through various news outlets, I guess. I'm very happy to share that knowledge always with people. And I'm going to give you my overall view on where we're at with COVID and where we might be going. And hopefully one day we won't talk about it. Wouldn't that be tremendous? I'm sure you'll all be relieved, as will I. Are we winning the war? There's my title. There's no doubt we are. And we've seen tremendous progress. And one big bottom line is science has delivered. I mean, the science behind those vaccines is quite remarkable, which I'll be describing briefly. My other, as I say, area is therapeutics. I'm going to mention how there's been great advances in therapeutics in hospitals as well. So we're seeing a lot of sort of interesting developments scientifically that have turned into really tangible benefits to all of us. And we can thank all the scientists and companies and investigators and doctors who are participating. Huge global effort, tens of thousands of people. My lab was pretty typical that we switched into COVID, as did many labs, because we realized, when was it, March 2020, of the nature of this emergency that we were all embarked in. Now, how can I say we're winning the war? Well, this next slide really captures the triumph of it. And way back in June 15th, on the left-hand side, 2020, there were no vaccines approved. Now, there were several in development in phase 2 and 3 and so on. You can see them there. Look what happens a year later, June the 8th, 2021, 8 vaccines are approved globally. Fantastic result. 4 of them in Europe by the EMA, of course, and they're the ones we're deploying in Ireland now. And then there's many more coming. I mean, look at the list there. You've got over like 120 more vaccines in development. You might wonder what's going to happen when all these vaccines arrive. Some won't make it. Some might be handier to use in various ways. So we're not at the end of this at all by any means. And as you'll hear in a moment, it is becoming about things like boosters to get the vaccines to work really well. It's also becoming about the risk of new variants, which I'll explain too. So even though we have these great successes, it's still very much a very active area for labs and companies developing vaccines. So watch what's going to happen. I think the 5th one will probably be Novavax, for instance, which is a protein-based vaccine. So we're still on this track, but without doubt, though, we have the triumph of these 4 big vaccines that were approved in Europe, as everybody knows by now: Pfizer, BioNTech, AstraZeneca, Johnson & Johnson, and Moderna, and they're all remarkable vaccines. There are differences between them, as we know, but if any one of those would have been a success story, remember. So it's a real triumph, and that's the word I've used. And in my dealings with the media, it's been very heartening. I mean, it's been the best of times and the worst of times, because anybody who stepped up to speak in the media were attacked by lots of people, trolling and all that. But more importantly, 90% positivity. And about 3 months ago, an elderly lady made a bit of lace from me. People think with hope on it, because obviously that was always the message, that we could be hopeful that we would get out of this. And that business of, being attacked, I saw a great cartoon. I always laugh in the face of this. Great cartoon. I've considered studying to be an infectious disease specialist, but now I worry that half the country would be mad at me. So that's kind of what was happening. But as I say, so many of us have stepped up, and my great colleagues, Kingston Mills, Clino Farley, Clino Nicatic, all over the country, immunologists and epidemiologists all stepped up and got the information out there, which I think is really important that we do that. That's our job in some ways. We're paid in universities to communicate, aren't we? And we communicate it to the general public in that way. And there's me getting the vaccine, May 18th, 2021. Great day in the Aviva Stadium. I was there, and a photograph was taken for the Sunday Independent, who I write for occasions. I would love to see that. And then a couple of other quick things before I get into a bit more detail, I guess. I mean, a really important part of this were 2 Irish scientists, Adrian Hill and Theresa Lamb in Oxford, and they were part of the big Oxford AstraZeneca vaccine. And this is dated, let me just remind myself, November the 24th, 2020. Now, they just released their clinical trial data, and the Sun featured a gift of the jab. Top Irish boffins behind miracle COVID drug. And one other interesting thing, maybe make you smile. Barbie dolls, watch this. So Barbie dolls are interesting because for years it was just Barbie. But then they realized they wanted more positive images for young girls, and that you can get all kinds of Barbies now. You can even get a science Barbie, which is fantastic. And look what's happened. Sarah Gilbert, who led the vaccine campaign in Oxford, they made a Barbie doll for Sarah. Isn't that tremendous? That might inspire lots of girls to become vaccinologists. You never know. And I know Sarah, and I sent her a slide. I said, I'm happy to be Ken to give you a hand. So it's interesting how these things have happened. Now, a bit more serious. Once the vaccines were there, and this happened in November of 2020, the data began to emerge of these highly efficacious, safe vaccines. Deployment became the mission. And I sent this out as a tweet, actually, to just explain how vaccines work. And it made it very clear. And I think people appreciated this because it made it so simple in a way. So if you're unvaccinated, there will be severe disease and death. That's the red Lego block. There will be moderate disease that can be very serious as well, and give rise to long COVID, all kinds of things. Many are mild and asymptomatic because it's a disease that's linked into age, comorbidities. If you vaccinate the population, everybody's nearly blue because the vaccine has protected. And we know these vaccines actually are fantastically effective at protecting against severe disease and hospitalization and death, and that's what these vaccines do. You may still get infected, and that's not a surprise. But if you do get infected post-vaccination, the vaccine will do its job and protect you and stop it progressing into severe disease. And talk about a level of data unlike any other vaccine ever. We know more about this virus than any other virus ever. The vaccine is not, these vaccines have been in about 5 billion people, huge safety data, huge effectiveness. I mean, it's a remarkable success story, and everything is held up. And of course, there were worries. And in fact, one of my jobs, and many of us, was to campaign against the myths that were out there. Was it too fast? You see the top one, it'll change your DNA. You might catch COVID. It might have funny things in it, like egg proteins. It might cause severe side effects, or it might make women infertile. These were all rubbish. The facts were this was not the case. And our job was to just put the science out. So look, here's the evidence against this. And the evidence was compelling that these were safe and that these myths weren't true. And that's the way science is supposed to work, by the way, to confirm these things. This slide here tells you it's a greetings card from an immunologist. May your reactogenicity be minimal. Your neutralizing antibody titers high, your T and B cells differentiated, and memory cells excellent affinity maturation. That's what you want with antibodies, and that's what these antibodies have delivered. Now, remarkably, our country performed hugely. We're number one, or in the top 2 or 3, it does move around slightly, at the rate of adult vaccination. There we are. This is about 3 weeks ago. 90% of the over 18s. I think it's 93 now, although it could be corrected, but certainly a very high level of vaccination in Ireland. And look what's happening. It's tremendous. It's saving people. It's stopping our hospitals being overwhelmed, especially with Delta, because Delta is much more transmissible. As a result, the dose is higher, more severe disease. If we didn't have the vaccines, our hospitals would be overwhelmed with Delta because it had changed from the original virus. So again, a great thing that we should all be very proud of. And now the next question is vaccine sharing. We must get the vaccine out to developing countries. They need it desperately. There's many people unvaccinated or vulnerable there. And there's the risk of new variants cropping up, because every time the virus divides, there's a risk of a new variant, and that may be different. That might cause problems in terms of transmission, as we saw with Delta, more severe disease, and even dodging the vaccines. And that means we go back a few steps. We can still make a vaccine against a variant, but there's a risk of that. So we must get vaccine equity, and we must proceed with that. And here's the variants. You're all familiar with them. Delta is the one that's now dominant. It's been dominant on the right-hand side there. It's been dominant now for a few months. No more variants have come in, which is a good sign. This may be, you never know, as bad as it's going to get, although we don't know that, but still, there's good news that the vaccines are holding up against Delta. And this slide really captures this. This is the effectiveness of the vaccines against Delta. Over 90% efficacy and protection against hospitalization and death on the right-hand side. So now you will see breakthrough infections with Delta, but they're not progressing, or at least as massive, 90% massive protection, by the way, in the vaccine business. So it's great news that the vaccines are holding up. And there's a cell to show you. This is the memory B cell. This is the cell type that the vaccine brings out. And this goes into your bone marrow and waits. And if you get infected, it gets mobilized and makes loads of antibodies to neutralize the spike on the virus. So we know enough. That was actually a memory B cell. I got this from publication a few months ago, taken from an 80-year-old woman who'd been vaccinated. Now, the other question we have, apart from the variant question, boosters. Now, as we're watching this emerge and evolve and develop, there is a need for boosters. There isn't a need for them in the general population. That's a Lancet paper. So for most people, the vaccines are holding firm. But the evidence is, although they're still very protective against risk of death, they're waning slightly against severe disease and hospitalization. especially in clinically vulnerable people. And this is the case with Pfizer and AstraZeneca particularly. And there's less protection against severe disease in people over 65. And what's happening is there's about a 20% waning happening 6 months out. Now, what does that waning mean? It's 20% less effective at protecting against severe disease. It's still 80% of the people would be protected, but 1 in 5 who otherwise would have been protected, maybe it's waned, and then there's a risk of disease in those people. And so we need now to give boosters, and that's what's happening. And there's great data from Israel. They were the first to see this waning event because they vaccinated with Pfizer earlier than other people. There's a 3-week gap actually in the Pfizer protocol. That might have been too short. 4 weeks looks like it's better. You get a stronger response. And maybe that's why Israel has had an issue more than other places, possibly. That's something that we're discussing. But now they're vaccinating everybody again, 3 million people, and the immunology is remarkable. They've got 10 times the antibody level after the 3rd shot compared to the 2nd. Huge boost. Again, this is expected with vaccines. Some vaccines are 3-shot vaccines. For example, hepatitis B. Some are even 4 shots because that really gets the immune system going. You get this thing called affinity maturation with every shot. And that means the antibodies have high affinity and they're very mature, which means they're very effective, And now we know in Israel, the boosters are working great. They're reversing that trend towards increased hospitalization in certain groups. And that's really good news. It means the boosters are working. And look at this, there was an 11-fold, the bottom line in that slide, 11-fold decreased risk of infection in the over 60s after boosting, whereas before boosting, there was a 3-fold increased risk. So this is a waning. So we know that this is working, this booster campaign. And now in Ireland, in England, by the way, let's put this one in. They're starting their campaign, everybody over 50. There's the timeline. So by the time you get to January, everybody over 50 is going to be boosted. In Ireland, we're beginning our campaign, of course. People over 65 in care homes, the over 80s. And I think we should move to everybody over 60. Because of the evidence of waning in people over 60, it makes sense. And we want to protect everybody as much as we can. And it wouldn't surprise me when we see that recommendation. I'd certainly be an advocate for that. Some studies are showing maybe over 50, actually, I saw last night, but we don't know. Certainly the data at the moment is over 60s, 3rd shot, especially with AstraZeneca, because that's the one that's waning a bit more than Pfizer. Still protecting a lot, but it's still waning slightly. So that makes scientific and immunological sense. And we may end up, by the way, with a green vaccine to stop any strain or any variant. It's very strong, and lots of efforts are underway to keep developing better vaccines, which are down the track. And we may see boosters with variants, could be Delta. You use a vaccine, it's quite straightforward to make these vaccines. Now finally then, before I wrap up and give you my view where we're at, where we're going, the other bit that I'm more interested in my own lab works on inflammation. And I worked on inflammatory diseases for decades. And COVID is an inflammatory disease of the lungs, where the virus goes out of control, the immune system can't contain it. Now it really starts to irritate the lungs and causes this inflammatory process, which ultimately means, damage. And breathing difficulties and all sorts. So therefore, there's been efforts to develop anti-inflammatories. And again, we've seen great success here. And drugs were redeployed from arthritis, for example, which is an inflammatory joint disease, and they worked in COVID. Other drugs that were there years ago were tried again, and new drugs have been developed. Now, this is a list of drugs that have been approved in various countries, and these are being used in Ireland as well, that are showing efficacy in terms of damping down the inflammation. Of course, what I'm talking about here is if you're unlucky enough to get infected, there's now options in hospitals to treat those people. And that's fantastic. And there will be people getting infected because the vaccines do the vaccine efficacy does, we see breakthrough there. People are unvaccinated, and make sure you get vaccinated because it will develop into severe disease, the risk of that. But still, there are therapies. Dexamethasone, that's a steroid used for years. I worked on that as part of my PhD, actually. That's dampening down the lung inflammation. That saved over 1 million lives. Actually, it was first shown in the UK. A drug called baricitinib, anti-inflammatory again. Tocilizumab, it's like a whole language. That blocks a thing called IL-6 that's inflammatory. And then these antibodies, they're called MABs, monoclonal antibodies. They were used experimentally on Donald Trump, for instance. They were genuine antibodies. And they were always going to work. I mean, they're basically antibodies to the spike. It's called passive immunity. You give someone a big injection of these antibodies, it mops up the virus. And of course, the vaccine brings out the antibodies and is 100th the price. So the vaccine is a better option, but still, antibodies can be used as a therapeutic to treat this. And then there's antivirals, remdesivir, that works a bit. It wasn't that impressive. But look at this one, molnupiravir is the latest one, developed by Merck, the drug company. Last week, or a few weeks ago, I guess it is now, they developed this, and the trial was remarkable, 50% decrease in hospitalization. That kills the virus. It targets the RNA polymerase and stops the virus replicating. Now, that's a really good weapon to add to all the other weapons that we have. You could take it orally as a tablet. and it'll stop the virus. And then interferon beta, that's a natural cytokine that your body makes. These cytokines, we work on them in my lab, they're proteins in the immune system, it's antiviral. We think young children are very protected against this, right? So they make loads of their own interferon beta that kills the virus. As you get older, you make less. And that's one reason why it could be disease of aging. That can be used as therapy. You can inhale it. And some of these are still in development, but they're all there and they're very interesting. And combined, there's enough therapeutic options here for doctors to use. And this is quite a complex slide, but it captures the whole of COVID in a way. The black line is if you get infected. It starts early, you get lung involvement, it goes systemic, and now you're in hospital and severe disease. It's the inflammatory phase is the one that the therapeutics or the anti-inflammatories you see there are being used to treat. Of course, early on, you want to give antivirals to stop the virus, and then the vaccine prevents disease. And remember, vaccines are always preferable because prevention is always better than cure. Now, finally, the possible scenarios that we're facing. There's no doubt immunity is building up in the population, as would have happened in the medieval times, because that's the way the immune system works. It gives you immunity, it protects you, provides immunity. And it's building up. It's fantastic all over the world. We're getting natural immunity from the regular infection and the vaccine, which is the safest way to build up immunity by far, which is great. So this is the way out, of course, is through immunity. Therapies improving. Issues around access and costs are in our minds, but we have these therapies. Essential to get the vaccine out to all countries. Vaccine equity, we call that. And then the boosters will be needed for the older and the vulnerable people. That should be done in parallel. So the goal really is get the booster campaign going and give your other vaccines away and make sure that you get them to developing countries. Should be the campaign that is underway now, and let's keep pressing that because it's essential. And then bottom line, we will exit the pandemic. And 80% or roughly 80 to 85% of the world's population has either been infected or is fully vaccinated, or a combination of both. When you've that level of immunity, the virus can't really spread because there's big gaps between two people who aren't immune. They can't really spread between them and that kind of thing. So, we're heading towards that 80% level now. Of course, we are. That's the entire population. And we're very close to that. So this is the way out. And then the pandemic ends. And then it will go endemic, and it's almost endemic already, which means it'll still crop up from time to time. But we'll vaccinate the vulnerable like we do with flu every winter potentially, and then we will have therapeutics in hospitals. Finally, I would say this in maybe a couple of years to come, if you do medicine in university in the infectious diseases chapter, after malaria and TB and other coronaviruses, it'll be COVID-19. It will say this is a preventable disease with vaccines. And it's also a treatable disease with therapeutics, and then that's the way it's going to be. So there's no doubt that's going to come. And of course, there may be slips along the way, but we're heading in that direction. And the big thing we have to thank for that, without doubt, is the vaccination campaign is the number one reason. And then finally, my new book is coming out, I'll plug it briefly. My new book is called Keep Calm and Trust the Science. And if we trust the science like Spock, we'll live long and prosper. So thanks very much.
It was very nice listening to Luke, who gave really an overview of the vaccines. And I think what we're going to do now is provide maybe another layer to that as we talk about them specifically in relation to COVID in the last year and the whole unfolding over the year. And of course, the big question that we all have, are we there yet? And many people have never heard of NIAC before the last 18 months. And you're absolutely right. I don't think anyone would have known anyone who was on it before then. None of us expected it, but everything changed. So who are we? Well, basically, we're a group of people who've been involved in healthcare and specifically in vaccines for many years. Originally, it started off back in the 90s, trying to collate the information around vaccines into one place that was readily accessible to healthcare professionals. And then it grew in the sense that realized that also the public wanted access to that. So the national guidelines went up online. They're available through the HSE website. And there are representatives from the College of Physicians, College of Surgeons, General Practice, Institute of Obstetrics, National Immunization Office, and all the different faculties. So the different people that are involved where vaccines are important, for example, occupational health, but also the virologists, the microbiologists, travel medicine, and lay members. So that's who NIAC is. So it's quite a big committee. And before COVID, we would have met every 2 months. There would have been busy times if new vaccines came out or guidelines needed to be updated. And then there would have been the quieter times in between or the still waters. This time has been different because first we went from maybe bi-monthly meetings to every month to every week. and in fact with a core group meeting many times a week, such that it has essentially usurped everything else that we were doing. It was all a voluntary committee, so people were doing this after their day jobs completely, and that was until last year, just before COVID broke, when it was realized that the demands around vaccines, the need for information, particularly around, for example, the HPV vaccine, had really increased hugely. And at that time, we got a little bit of funding for 2 part-time scientific advisors. Just at that time, I think it was 8 hours per week, so very little to help us. And since then, because of COVID, we're now in a position where we have got a program manager. But what we need to do is actually to move to a fully funded, established NITAG, and that's what is recommended by WHO and by Europe, a National Immunization Technical Advisory Group, because really the information on vaccines in general, it's not just COVID, it's HPV, it's new vaccines coming in different areas. We've just heard about the malaria vaccine being developed, and all of that needs to be kept under review and the information kept up to date. So at each of our meetings, there are representatives from the Department of Health, the HSE, and the HPRA, because they're the safety agency that looks after that. And underpinning all of that, we also link in now. In fact, coincidentally, just before COVID, it was established a European working group, or an EU NITAG, to come together so that we could share, that not each country was trying to do their own little bit, but we could share the information. And then, of course, we get specialist input as required. And particularly in COVID, we've worked very closely with HICWA in terms of making sure that we've got the right evidence and that it has been synthesized appropriately. So a lot goes into those meetings. Whoops, this isn't moving forward for me. Oh, there we go. But with all vaccines, there are some basic questions, and that is, are they needed, are they safe, and are they effective? And already, as I said, Luke has shown that graphic where we know that, for example, with COVID, and we'll take that as the sample, as it were, that although there's a lot of mild disease with COVID, that some people can get very ill. When we're planning then for any vaccination program, there are some basic guidelines that we have to follow. And there are the sort of the direction, that vision that Sonia talked about. What is the ultimate vision, and then how do we get there? Well, in this case, it was really to prevent morbidity and mortality. That was the most important thing. If you think back to the beginning of it in April 2020, when our ICUs were being overwhelmed, the hospital system could no longer work. So we also needed to protect healthcare capacity. And of course, we wanted to protect essential services, and in as far as possible. And I recognize that there has been so much disruption to normal social and economic life. That was one of the goals as well. But all of that had to be done in an ethical way, recognizing the moral equality of individuals, where everyone really is equal to the other when it comes to health, that we wanted to minimize harm, do it in a fair way. And yes, there was a need to think about reciprocity for those who are putting themselves on the front line. And with that framework, then we approach the questions: are vaccines needed, are they safe, and are they effective? So let's go back a little bit to the virus. So this is a graphic showing the virus here. It's the coronavirus with the RNA, and that's essentially the blueprint, or the architect coming in with the instructions to the cell as to how to make more virus. So the virus comes, it attaches to the cell, it releases that blueprint, and the cell then reads it, makes viral proteins, and makes more virus, because that's all the virus wants to do. In that process, the virus is seen and meets cells of our immune system, like those memory B cells, or in fact, the acute B cells as well, and the T helper cells, and they start making the antibodies. But also those other cells in the immune system, the cellular cells, they recognize the virus, and they have their role to play, including the long-lived memory. So that's what the virus does. So what do vaccines do? Well, vaccines try to mimic that. So what the vaccines do in many different ways, and we'll see that, is they mimic this spike protein that attaches to cell, that goes in, and it gets in different ways with the different vaccines, and we'll look at that in a minute. But basically what it's trying to do is to fool the immune system to respond to the vaccine the same way as it would respond to a virus, and generate the protective antibodies, and also to teach the cells how to respond. Because in a way, this is teaching, these are the front lines, the antibodies, the ones that come quickly. But down behind that, you have the cells that keep, that are the reserve forces, so that they're ready to deploy over time. And here is just a simple graphic. We spoke to this really in terms of what happens as to why we need these vaccines. And it is because although most of the disease will be mild, particularly in the younger age groups, we know that across all the age groups, there can be some who will follow a more severe trajectory and end up getting very sick, ending up in hospital and even dying. And as you go up in age, right from the beginning, that has been the single most important correlate of why we might become severely ill and end up in a bad situation. And likely that correlates with the normal aging of our immune systems to some degree, because there is this concept of immune senescence, whereby we do not respond as well as the younger children. And there you can see how children generally, in fact, have mild disease, whereas when we get up into the extremes of age, it's very difficult to deal with COVID. So then the vaccines came, and we thought it was the beginning of the end, and everybody thought, straightforward, let's do it. Well, that really wasn't the case, because the reality has been more like this. Why so? Because on the one hand, we've had a virus who hasn't played ball. It keeps twisting and turning. It has developed capacity, increased transmissibility. In some situations, some variants, but thankfully, they aren't the most transmissible variants. It has become a bit more resistant. But on the other side, we have the forces. We have an array of vaccines that have been developed, yes, in the last year, extremely quickly, but not when you think of it overall, because in fact, people have been working towards this goal for many, many years. And so the platforms were all there, ready to go when they had a new virus that needed a vaccine. So that sense that it all happened in the last 18 months before the vaccines came, actually that was stepping on the shoulders of the giants who had gone before. And in fact, if you were to say how long these vaccines are in development, it really goes back not 10, but maybe 20 or 30 years. So what do they do? Well, here's just a characterization, for example, of the cell. Here are the viruses, and we have a range of vaccines. And all of them, as I say, are trying to do the same thing. They're trying to fool the cell, so they think that the virus is there, and they get the immune system to respond in the same way as it would do to natural infection. Here are some of the ones that you're most familiar with, for example, the Pfizer vaccine and the Moderna vaccine. Now, this was a totally novel technique that had reached readiness to be used in the field. And what it was is the scientists had taken the RNA that coded for the spike protein and actually were able to stabilize it enough such that they could inject it, and it was taken up by the cells and could quite cleanly inform the cell as to how to make their antibodies. Over here, we have the viral vector vaccines. And what they are is basically they're a bit of a Trojan horse, because they take another virus, but it's inactivated so that it can't turn over and make more infection, in this case, an adenovirus. And into that, they put the blueprint, in this case, DNA. And then that is given into the cell, which opens it up, takes out the DNA, transcribes it to RNA, recognizes it, and starts making the spike proteins as well. More traditionally, up here, we have inactivated virus, where they take the coronavirus and they inactivate it such that it can't cause infection. And we have Sinopharm and Sinovac. Some of you will have heard of Coronavac, that's a Sinovac. And now we've just got data just this week on a European Valneva that has been formed, and the results from it look very, very promising. And that can be given, so that's a more traditional form. And then over here, finally, we have where you just take a little bit of the protein and you give that. And this vaccine also is probably going to be available early in the new year. This would be more in the technology like our influenza vaccines, a subunit protein vaccine. But all of them are doing the same thing. They're informing the cell how to make the antigen, the protein antigen that stimulates our immune system. So the first step is you have to see, do they work? And what you want if you put them into a study is you want results somewhat like this, where you get those that have the vaccine, whichever vaccine, and they are not having the bad events, and you get those who didn't get the vaccine and the disease is going on. But you want them in that safely, I forgot to move that, that should be down here, the vaccine group, that they are safely protected. So that's an ideal scenario. You don't really expect to get results that are that definite when it comes to clinical trials. But in fact, to everyone's really surprise this time last year, the results that were coming out, whether it was from the Pfizer vaccine or the Moderna vaccine or the Janssen vaccine or the AstraZeneca vaccine, they all showed this wide separation, which really is saying they showed the wide benefit that the vaccines afforded to those who were vaccinated. And we didn't know right from the beginning that there was a differential, because the benefit against someone simply getting a mild disease or having symptoms, though very good, wasn't as strong as the benefit against hospitalization. And I'll come back to that point. But incredibly, against hospitalization, and this was back with our ancestral strain, all of them were almost essentially 100% protective against hospitalization. Now, when you say hospitalization, you know in the real world, nothing is 100%, but they were very, very close. Now, in those trials, that's what we refer to as efficacy, whereas what we really want to know is effectiveness. So what's the difference? Well, in a clinical trial, you're taking a control set of people, very often people who are healthy, they don't have significant underlying disease. For example, in these trials, there was no one with immune compromise. So it's quite a control setting. And the results that we get from that controlled environment, we refer to as efficacy. What we really want to know is how well that translates when we put it out into the real world, where you're not just dealing with a select population, you're dealing with everybody. And you're also dealing with all the situations of getting the vaccine from where it's made into the arms of the people and what their ultimate response is. And that's effectiveness. But these vaccines held up. And I've just taken a couple of examples here to show you, but it could be, there's several studies that would have mimicked this. Here is from Texas, where they were showing those who were not vaccinated, partially vaccinated, and fully vaccinated in terms of getting COVID, and just showing where the virus levels were going before they introduced the vaccine, and then it fell down. Here's Ireland, when this correlate the numbers of cases of disease, and then those as the vaccine uptake was going up. But where are we now? Because we've got 92% of those over 18, and it's probably a bit higher even now, it keeps creeping up, are fully vaccinated. And of the whole population, probably 74%. And the pie chart here is showing you the different vaccines that have been used, predominantly Pfizer, but a good segment of AstraZeneca, and then some of the others. So, and yet, what's happening? And I suppose this is what's really topical, and what we couldn't have predicted when this session was planned. But what we've seen most recently is this upswing in cases that has even got a little bit more exacerbated in the last days. And we heard, Leo Varadkar talking about, are we in for twin peaks? So why? Well, there are a number of contributing factors, and to try and tease it out, I've divided it in this way. We have our population, we have the virus, and we have the vaccines. So with the population, we've all heard that there's a large cohort who are remaining unvaccinated, and you're going to have more discussion on that. And it's not in any way to vilify, as some have said, we're doing those who are unvaccinated, or stigmatize them. We do not want that. It's trying to understand the myriad of reasons that goes into that. Because it can vary from the simple fear of getting an injection, which can be very real, to those who are absolutely adamant that they are not going to go this road. But that is a small minority. And we really want to address the fears and concerns that sometimes can be very reasonable, where people just need more information in a way that they can understand it and from people that they trust. Now, the other factors, of course, that have gone on as well is that there's been more social mixing. And that has been the message that we're getting as well. We have to recognize that we've encouraged this gradual opening up, but it has, unfortunately, with the current virus, had consequences. Then there's simple facts that sometimes we forget to do, the things of sanitizing our hands or using our masks. And we know that this virus is transmitted in a number of ways, not just by hand contact or by respiratory contact, but to a certain extent, especially in closed environments, it may be transmitted in airborne as well. And so we need to tackle on all those fronts, remembering to have good ventilation and do all the other things. But what that has done is that the force of infection in the community has increased. There are a lot more cases circulating. And what that will do is it will pick out those who are vulnerable, those who maybe couldn't respond to the vaccine, or those who are unvaccinated. And we've seen that result in the hospitals today. What about the virus? Well, there have been changes there too, because we've had the Delta virus. First, it was the Alpha virus, and that had some increased transmissibility. And now we have the Delta virus, which is even more transmissible, but fortunately isn't really associated with any more serious disease. It's just that it is affecting more people. Now, the Beta virus was a little bit more resistant to the vaccine, but fortunately, it didn't get that increased transmissibility. So it hasn't become a real problem, and Delta has been to the fore. And you've heard Luke say, well, maybe this is a relatively good thing in the sense that Delta has keeping its place and we're not getting more resistant virus coming in. But that's not to say it can't happen. And then what about the vaccine? Well, some people haven't got the capacity to have a good response to vaccine. For example, those who are immunocompromised. Now, I know in the media in the last couple of days, there are people talking about Colin Powell and seeing that as a reason why he shouldn't get vaccinated. But let's talk about that. He was fully vaccinated. He was 84 years of age. He also had underlying disease, multiple myeloma, and he was on immunosuppressive therapy. So in fact, he is very much the type of person that we would recognize that we need to protect by the rest of us reducing the transmission of infection and the circulation in the community, because vaccines alone will never give that 100% protection to 100% of the people. And then the other factor, we know that there has been some waning in our immune response to the vaccine, but we're going to look at that in a little more detail. This is just looking at sort of the population, and this graph just came out this week, so there's some very topical data there. But you know, what's happening? Why is this increased circulation happening? Well, I just picked out a couple of points to highlight for you. People worry about schools, but actually look there, that's when the primary schools closed. It was after the schools closed that there was the first uptick, because that's we're all beginning to get together again, the beginning of the summer holidays. There's our increase in outdoor. That's when we started outdoor dining. There's our indoor dining. There's when the schools open again. And here's our return to the workplace. Now, I'm in no way saying we shouldn't have done any of those things, but it's just that when we open up, and we are going to be opening up this time, we have to remember that this virus is canny, it's out there, and we just need to try and think about how we get safely through it and keep doing all the things. Remember to keep our distance a little bit if we can. Remember to keep our ventilation good. And a lot of it has been attributed to the fact that this virus, the Delta virus, is so much more transmissible than others. And this just shows graphically how first we had the Alpha, and here's the resurgence with Delta that in fact has paralleled this increase in case numbers. And it's very difficult to tease out. Is it all just because of the Delta virus, or is it because our immunity has waned a little bit from the vaccines because we started them, you know, now 10 months ago? So it's a combination. And on top of that, we have brought in the more social mixing. So it's all those factors coming together. But are the vaccines still effective? Well, here's data from the US and showing the numbers of cases of COVID, the different peaks throughout the time. But here we can see in the vaccinated population, the fully vaccinated population, the hospitalization rate. So they have not paralleled the numbers of cases. In fact, in the US, between January and July, those who are unvaccinated were 17 times more likely to end up in hospital. And in June to July, which would be the Delta period, they were still 10 times more likely to end up in hospital. So we're talking a lot about waning immunity. What does that mean? Again, this is a study from the US in a large healthcare system, more than 34,000 individuals for over 45 years of age. This is the change in the variants. Here's the Delta variant coming in. And what we can see here is that the protection against infection, there has been some decline over time due to that combination of factors. And what we see, though, is the protection against hospitalization has in fact been held up very well. And this is data literally just released yesterday, and I thought we'd have a look at it together to see what does it tell us, because this is from the UK, population-based. There are some caveats about it, but they were looking at the different periods between what we call the alpha period and the delta period, and what your risk was of having a positive test. Now that's whether you had symptoms or not, but actually getting infected versus developing symptoms, not necessarily hospitalization, but developing symptoms. And they looked at those who were previously infected. Now they couldn't separate out whether they were just previously infected and had got vaccines or not, but previously infected. And we know that natural infection confers a level of immunity. And they looked at whether you had any vaccine, 1 dose or 2 dose, and which vaccines they were. So the messages as we look at that are that the first thing to take home is that if you've got 1 dose of vaccine, whether it's in the alpha period or the delta period, whether it's in the alpha period or the delta period down here, and 1 dose would have lower protection down in the delta period, you need your 2nd dose. You need to complete your vaccine to get up as high as possible. The other thing that we can see from this is that the protection against symptoms across the board is higher than against infection. And that's our immune system is very good at protecting our lower respiratory tract. The antibodies work very well there. When we have very high levels of the antibodies, they probably work quite well in our nose, but over time, they don't have the same effect, and so we can get infected. And the other thing that has changed in these 2 time periods is that when we get infected, even if we've no symptoms, our levels of a virus are as high in our noses as they are in someone who had had no vaccine. Now, it doesn't mean we get sicker, but they're higher there, so we can transmit it on. Probably not as effectively because they don't stay as high for as long, so we mightn't transmit as well. But overall, if you've had 1 dose, you need your 2 doses. And yes, in the Delta period, particularly if you've had only 1 dose, we know, and particularly with the AstraZeneca vaccine, the protection has fallen off a bit, but you've still got very high levels against getting symptoms and even higher against hospitalization or ICU. So where are we now? In April to October, this is looking at our hospitalizations in Ireland, and 40% of hospital admissions and 69% of ICU admissions are in the unvaccinated. Now, when you say 40%, then you say, well, 60% are in those who are vaccinated. But you have to remember that only 10% of the population are not vaccinated. So that's a huge overrepresentation. So those who are unvaccinated are carrying the biggest burden of disease in terms of hospitalization. Only 21% of ICU admissions represented breakthrough infections. What do I mean by that? They occurred in people who were fully vaccinated, were 14 days after their 2nd dose of vaccine. And 97% of them had significant underlying medical conditions, for example, immune compromise, or were older. So these are the people we have to protect. And in terms of deaths, again, the median age was 82 years of age, 50% unvaccinated, median age 82, 66% with underlying medical conditions. So that's who we must protect. So booster doses, are they needed? Are they safe? Are they effective for whom, when, and how acceptable to be? And again, when thinking about booster doses, we always have to balance benefits and harm and think about that ethical framework. And the other thing we have to think about here, and Luke alluded to it as well, is that this isn't just a problem in Ireland, this is a problem globally. And we are a global village. And if we don't do our bit in protecting the world and facilitating that protection to take place, this pandemic will go on even longer. So we do want to use the vaccines to protect our vulnerable, but we want to use them where they're needed and when they are needed. So we can do it. What we recommend is that when you are called for vaccine, be it the primary course or now for the boosters, get vaccinated. Vaccines do save lives. They have saved countless lives during this pandemic. And at the same time, we have to recognize the tragedy of the lives that we have lost. The vaccines are safe and they are protective. And if you need more information, please reach out and seek it from a trusted healthcare provider. There are good websites with good information. They will protect you and they will protect others. They will protect your family and they will protect your community. And they do save time and money, because if we can get the whole thing under control, then economy can get going again. And that is important for health, and they will protect our future generations. So what we need to do individually is keep up our guard, and we can then protect ourselves and our family and our community. And so I would like to acknowledge everybody, and particularly the people of Ireland, in really dealing with COVID and being part of the team that extends far beyond the Health Service Executive or the Department of Health or NIAC or any of those, but really extends out into every corner of Ireland. Thank you.
Good morning, all. Thanks very much for the invitation. Luke mentioned earlier on about winning the war against COVID. I think kind of we all owe Luke and Karina a huge debt of gratitude, and organizations like Midland Science, for ensuring that we're sufficiently informed and educated, and that we have the confidence to seek out and demand vaccination and to ensure that we do our part. And it's one of the things I think kind of that probably has maybe been overlooked a little bit this morning, is the importance of that communication, the importance of informing the public and ensuring that their concerns and their fears are allayed, and that they have the confidence to seek a vaccine. And so that's what I want to focus on this morning. I thought maybe kind of given the remit of your SFI Discover project in terms of science communities, and that you want to engage the public in dialogue and discussion around understanding science, and that I'd probably maybe kind of give your audience a little bit of a look around or behind the curtain in terms of what a team of research psychologists do when it comes to tackling something like vaccine hesitancy in a pandemic such as the one that we're living through at the moment. So as was mentioned, I'm a member of a very large consortium of research psychologists from institutions across the UK and the Republic of Ireland, and institutions in Spain and Italy and Saudi Arabia, the United Arab Emirates. And we came together at the start of the pandemic, the very start of the pandemic, with a collective decision and intention to monitor the psychological impact of the pandemic on our respective populations by conducting nationally representative survey research. And one of the early questions, I guess, for our team was, how could we as psychologists put our shoulder to the wheel? So while immunologists, virologists, vaccinologists, epidemiologists were monitoring the pandemic and were rallying to develop safe and effective vaccines, we asked ourselves the question about how best might we prepare for the arrival of a COVID-19 vaccine in the earliest weeks of the pandemic and the lockdowns. So we wanted to know how receptive the population would be ultimately, how much hesitancy we might discover. Obviously, we wanted to be able to inform those who are responsible in charge of the care of the general population. We wanted to let them know about how receptive the population would be to a COVID vaccine once they arrived. We also wanted to understand vaccine hesitancy and resistance. So we wanted to kind of identify who would be hesitant and resistant, what characteristics would describe those individuals, and understand something about the psychology behind their resistance and the hesitancy. And very importantly, to understand where they source their information from and what information they trust, so that we can reach them and provide them with the necessary information to allay fears and to change their position. So we felt that a better understanding of the psychology of vaccine hesitant and resistant individuals might afford public health officials a more complete understanding of why these individuals think the way that they do, and provide insights to help design more effective communication strategies. So what is vaccine hesitancy? So the Strategic Advisory Group of experts from the World Health Organization have been looking at this for years. So vaccine and vaccination more generally prevent about 2.3 million deaths every year. And it's estimated that an additional 1.5 million deaths would be prevented if we could improve our vaccination services and our uptake of vaccines globally. So vaccine hesitancy is recognized as a serious problem and an obstacle to the success of vaccine delivery, and was recognized as one of the top 10 threats to global health in 2019, and has continued to be recognized as a very serious threat. And so they've defined vaccine hesitancy as a delay in acceptance or refusal of vaccines despite the availability of vaccine services. Now that seems quite clear and concise, but vaccine hesitancy as a phenomenon is an incredibly complex, multidimensional issue. And in order to address any hesitancy that individuals may have or to allay fears and concerns, it's first necessary to understand how complex vaccine hesitancy actually is. So vaccine hesitancy kind of is indicated and implicated in terms of perceived safety of vaccinations, and individuals' perceived effectiveness of vaccinations, perceived necessity of vaccinations, disease risk perception, so whether an individual perceives risk in the way that they should and believes that they should be vaccinated against that risk, concerns about side effects, whether those are common side effects or rare side effects. Vaccine hesitancy varies depending on the type of vaccine that we're talking about. It varies depending on an individual's underlying health issues or contraindications that may be present. It varies depending on an individual's phobias and fears, largely around needles or medical interventions more generally, or blood. Varies because of religious issues, and various issues around parenthood and pregnancy and fertility and breastfeeding are also very important in terms of whether people consider vaccination. And then finally and importantly, individuals' trust in political institutions, in the scientific community, importantly, in healthcare professionals, and in the pharmaceutical industry. So trust in all of these organizations and individuals is incredibly important for determining whether people are receptive or hesitant to vaccines or vaccination more generally. It's also, in order to understand vaccine hesitancy, we have to know what information people are using, where they're sourcing that information, and how they're using that information. And importantly also, to be very sensitive to the historical, political, and socio-cultural context in which we investigate vaccine hesitancy. So vaccine hesitancy is something that varies quite dramatically from place to place and over time, and it's something that we need to be sensitive to. So the World Health Organization SAGE group kind of tried to summarize this and condense this in terms of the 3 C's model, whereby if we can understand confidence around vaccines and the convenience with which people can receive and access vaccines, and also issues in relation to complacency, whereby people accurately perceive risk and the benefits of vaccines, that we will be better able to tackle viruses and pandemics like the one we're in at the moment. So critically, all of that information, that kind of deep and understanding of vaccine hesitancy is necessary to appropriately inform the public health messaging that we employ and design. And kind of we will have been kind of encountered much of this over recent months in terms of how vaccines have been developed. It's interesting to hear Karina kind of mention the timeline in terms of the development, whereby a lot of concerns and concern or fears about the current vaccines for COVID-19 are about the speed at which vaccines were developed. But as Karina has so elegantly kind of identified and explained, that development has been going on for much longer than people may realize. So explaining and describing and educating the public about where vaccines have arrived from, how they've been developed, and their safety, their efficacy, about side effects is critical in order to address any fears, concerns, and to kind of ensure that people are more receptive to vaccines. However, unfortunately, there are many people in the population who are resistant to science communication in this way. So we commonly adopt a deficit model of science communication, whereby we assume that hesitancy may be attributable to misinformation, misunderstanding, ignorance. And so what we do, our first step, our first port of call, is to try and inform the population as fully and as clearly as possible with accessible, repeated information. But some individuals, and a significant enough number of individuals exist in the population that are motivated to kind of resist scientific information. And so the model I showed you earlier on about all of the risk factors is only one part of the problem. In order to understand vaccine hesitancy, we not only need to understand all of those determining factors, but we also need to understand something about the machinery that is responsible, the psychological and cognitive machinery that is responsible and underpins attitudes, not only in relation to vaccines, but in relation to climate change, in relation to other issues, such as creationism or genetically modified foods, critical issues for science and for the general population. So if we look at some of these attitude roots, then we begin to see some of the things that sustain and maintain anti-vax attitudes in the midst of even the most compelling scientific evidence. So attitudes are kind of commonly identified as often as vehicles for defining one's core values. So the attitudes that people express and share with one another often are an attempt for an individual to kind of give you some sense of who they are as an individual. So they're essentially cultivating an impression of self, and the attitude becomes a means to an end. So whereby the attitude expression is essentially a social signal about who this individual is. So whether I am empathic, I am an individual, I'm rebellious, I'm not a sheep. And also kind of our identities in terms of who we are and the attitudes that we express also reflect our alliances and allegiances and our identity within social groups. So depending on who we are as individuals and the groups that we align with, the attitudes that we express often reflect the characteristics and the ideologies of the groups that we align with. So in relation to ideologies, several ideologies are important in understanding the kind of attitudes that are relevant in terms of vaccine hesitancy. So whether people have hierarchical versus egalitarian worldviews, where they are in social dominance orientation, their individualistic versus humanitarian worldviews, their free market ideology, the belief in a just world. And all of these factors determine how individuals view society and their place within society and how society should be structured. And often when their role, identity, freedom in society is disrupted, such as it has been through the pandemic, then people's personal costs and personal inconvenience in terms of many of the social mitigation measures, social distancing, hygienic practices, and vaccination lead people often to places where they experience discomfort and they're agitated and frustrated and angry about the situation. And they experience often cognitive dissonance at feeling agitated at the situation. So one way to resolve that dissonance may be to adopt attitudes and beliefs, for example, in terms of pandemics or conspiratorial views in terms of vaccines and the reasons behind vaccination. And they develop motivated skepticism. So people's attitudes are also underpinned by conspiracist worldviews. So these are beliefs that it is possible for vast networks of people to execute sinister plots in near perfect secrecy, and a unitary worldview that elites have malevolent intentions and engage in information subterfuge to push their hidden agendas. And so people, depending on who they are, their personal identity, their social identities, their underpinning ideologies, their vested interests, and the difficulty of a pandemic situation may adopt and may be amenable to and more receptive to conspiratorial worldviews relating to the pandemic. Also, as I mentioned earlier, people will have anxieties and phobias. So the attitudes that they profess and the positions that they take in relation to vaccines may be driven by these underlying fears they may have in relation to medical intervention, needles and blood and the like. So taking this type of information, kind of our team of researchers decided to look at vaccine hesitancy from a psychological perspective and begin to understand what vaccine hesitancy looked like in the populations of the United Kingdom and Ireland. So we sampled from a nationally representative samples in the UK and Ireland, over 1,000 individuals in Ireland and over 2,000 in the UK. And we've been following those samples over time. And we started with a very simple question at the start of the pandemic, the very start of the lockdown. We asked people, if a new vaccine were to be developed that could prevent COVID-19, would you accept it for yourself? And our respondents answered yes, maybe, or no to this question. And we classified these individuals either being vaccine accepting, vaccine hesitant, or vaccine resistant, determined by those responses. And in relation to that, the first thing we wanted to identify was how receptive the population would be to a vaccine. Now, remember, this is a year before vaccines, well, approximately a year before vaccines have been developed. And we're preparing to kind of inform the population about how receptive people are. And we could see that the populations of the UK and Ireland were comparable in terms of how many people were accepting, how many people were hesitant, how many people were resistant. And more people in the Republic of Ireland were resistant than in the UK. If we look at the devolved nations of the United Kingdom, we can see kind of concerning levels, kind of the earlier points of the pandemic, whereby vaccination acceptance was as low as 50% in Northern Ireland, and hesitancy and resistance was about 48%. And this again kind of highlights the importance of looking at the contextual context of vaccine hesitancy and being sensitive to the socio-political and cultural context within which you investigate this phenomenon, because there's notable variation here. Obviously, we wanted to identify who these people were. So we were able to kind of analyze our data. And again, this is just in relation to the Irish data, given the time constraints of this presentation. So I want to give you an idea of what Ireland looks like in relation to our findings. And so we were able to identify that hesitant individuals more likely to be female in the 35 to 44-year-old age bracket and to have no history of mental health treatment. That resistance was characterized by individuals in the 35 to 44-year-old age bracket, and they were non-Irish in ethnicity, living in a city, earning less than 50,000 euros, and that they'd voted for Sinn Féin or an independent voter in the last general election, and that they had an existing underlying health problem that would exacerbate their health if they contracted the COVID-19 virus. Very importantly, what we took an attitude roots approach, so we wanted to understand the psychology, so the factors that would sustain or maintain those vaccine hesitancy attitudes. So we were looking at a wide range of psychological factors, and we discovered that individuals who are hesitant or resistant were less trusting of experts, that is scientists and healthcare professionals, and authority figures, so that is the state. They were more likely to hold irrational beliefs, i.e. religious and conspiracy beliefs. They were more likely to believe that situations in their lives are under their own control, so internal locus of control, to have a stronger preference for societies that are hierarchically structured and authoritarian in nature, to be more intolerant of migrants in society, to be more selfish, i.e. less empathic, to be more impulsive in thinking style and problem solving, and to have more disagreeable personality. So you can see that we've learned a great deal about the population in terms of those who are hesitant, resistant, and that this information can potentially be incredibly useful for tailoring and targeting our messaging for the population. We also wanted to identify where the population were receiving their information and how much they trusted that information. And while hesitant individuals were no different to those who were accepting of vaccines in terms of where they sourced their information, resistant individuals were significantly less likely to source information from mainstream channels and government agencies, and they're significantly more likely to source information from social media. And importantly, again, hesitant individuals were no different, statistically no different from accepting individuals in terms of vaccination, but resistant individuals were significantly less trusting of mainstream channels of health professionals, doctors, and government. However, doctors, health professionals, and the sources they trusted were the sources that they trusted the most of all sources of information. So we also wanted to look to see how this changed over time. So these were longitudinal studies. So we started our investigations in the earliest stages of lockdown in March, April 2020, all the way up to when vaccines were introduced in December 2020. And these 4 different time points gives us a kind of an idea of the proportion of the population that was accepting to the vaccine. So we could see that declined the closer we got to the introduction of vaccines, and that hesitancy and resistance started to increase proportionally in the population from each of the waves up to the delivery of the vaccines. Now, important questions again that we wanted to answer at this point, and there's a tendency to think of people's attitudes towards COVID-19 vaccinations as static, but the changing figures of vaccine acceptance that we've seen over time indicated that people do change their minds. So we wanted to model this longitudinal change in attitudes and identify who is changing their minds. And what we found was that there were 3 distinct groups. There were a group of individuals who said yes at the beginning of the lockdown and maintained that position right up until the point where vaccines were introduced. There was about a subpopulation of about 16% that were resistant from the beginning and held that position right up until the point. So they were static and stable in their resistance to vaccines. And then there was another group that we called the movable middle, where they started with more positive confidence and attitudes towards vaccine receptivity. This declined and bottomed out in July, August 2020, and then recovered in late December. And again, so it's important to identify these groups in order to be able to recognize the proportion of the population that are receptive to vaccines and the proportion of the population who are entirely resistant, and those who may be reachable in terms of our public health messaging and obviously what that public health messaging should look like. So we might think about tailored or targeted messaging. So researchers have referred to jujitsu health messaging, whereby we use the underlying psychological factors that we know underpin attitudes to inform the public health messaging that we use. So first and foremost, the strategies employed by Professor O'Neill and Professor Barrett and Midland Science and informing the population about where vaccines originate from, about side effects, repeating this information, that is effective for the majority of the population. But to the extent that vaccination skepticism may be motivated by belief in a just world, it might be useful to present lack of action as a violation of justice to future generations. To the extent that rejection of Western medicine is motivated by fears about injection and medical intervention, it might be useful to focus on the role of immunization in reducing the need for injections and medical interventions once people get sick. In relation to the extent that people have a conspiratorial worldview, it might be useful to acknowledge the possibility of conspiracies, but show how vested interests can conspire to obscure the benefits of vaccination and to exaggerate the dangers. And finally, to the extent that people reject science because they wish to present a self-image of themselves as critical and skeptical, it might be useful to communicate the inherently skeptical nature of science, or to portray anti-scientific thinking as examples of unthinking conformity. So, thank you very much for listening.